Hello student, we are going to discuss class 12th organic question. Organic is basically NCERT part 2, and here I'm going to discuss NCERT and exercise question. Question number 19th, 6.19. Here in the 19th question, they are asking how to following conversion can be carried out. So basically it's a conversion question. So in that 19th question, we have a totally 19 question. So if you start with the first question, they are asking how to convert propane to propanol. So let's draw the structure first. Propane is CH3, CH double bond CH2. So basically propane to propanol, CH3, CH2, CH2 and OH. Okay, so here, so what we have to do first, we will try to convert this propane into CH2Br like this, and this Br will be replaced by OH by SN2 mechanism. We'll take it what OH minus, that is the SN2 reaction. So this Br will be replaced by OH simply by SN2 mechanism. But thing is how to introduce this H and Br, how to break this double bond. Just to break this double bond, we follow the addition reaction, and this is basically free radical addition reaction. In that free radical addition reaction, basically we are following the anti-Markovnikov rule. So for that we take HBr and peroxide. So this is the anti-Markovnikov rule. So I repeat, so here they are asking to convert propane to propanol. So here if you see, if you convert this propane to 1-bromopropane anyhow, then this Br will be replaced by OH by the SN2 mechanism. The thing is how to introduce this Br. Along with this Br, we are introducing H also, and basically we are breaking this double bond. So just to break the double bond, we follow the addition reaction, and here we are following the free radical addition reaction, and that rule is called anti-Markovnikov rule, because we need the Br outside. So this is anti-Markovnikov rule, and for that we take HBr and peroxide. So Br is getting added here outer side and H inside. So H is going to be added on the carbon containing less number of hydrogen, and Br is going to be added on the carbon containing more number of hydrogen. That is the anti-Markovnikov rule, HBr peroxide, and overall this is free radical addition reaction. And wherever we break the double bond and form the single bonds here, that is called addition reaction. Rule is anti-Markovnikov. So for that we have taken HBr peroxide, we have introduced Br here, and that Br is going to replace by OH. OH is the nucleophile, and overall this is SN2 reaction. So overall conversion, first conversion is over. I hope this is clear for everyone. Now second one is ethanol to but1 they are asking. Ethanol is what? I'll draw the structure of ethanol. CH3, CH2, OH. Okay, ethanol to but1, CH3, CH2, okay, C triple bond CH. So ethanol, so OH, basically OH is going to replace by this C triple bond CH, but directly we don't have any method to replace this OH by this. So for that we follow the indirect method, that is the SN2 method. If anyhow, if you convert this OH, if you replace this OH, if you convert this molecule into CH3, CH2 and Cl or Br or I, anything if you introduce here, then this Cl is going to replace by this nucleophile CH3C minus charge and Na plus. Okay, so this part will behave as what? Nucleophile, this negative part behave as a nucleophile. This will replace Cl here, and overall you have a but1. Okay, that's fine. But how to replace this OH by Cl? For that we'll take we can take PCl3, or we can take PCl5, or we can take SOCl2, thionyl chloride, SOCl2. Okay, this is the best method. SOCl2 is the best method, so we prefer to take SOCl2 here to replace OH by the Cl. This SOCl2 is called thionyl chloride. So second reaction is over. Here I repeat, in this reaction basically ethanol to but1 means OH of ethanol you have to replace by CH, C triple bond CH. So directly we don't have any method. So what we do, we convert this OH, we replace this OH by Cl, and for that we take the SOCl2 thionyl chloride. That is one of the best method. Instead of this we can take PCl3, PCl5 also. Okay, so OH is getting replaced by Cl, and now this Cl is going to replace by this huge nucleophile CH triple bond C minus. Okay, this part is the nucleophile, and this reaction will be SN2 reaction. Okay, so Cl will be replaced by this. Overall this reaction is zero. I hope this is also clear for everyone. Now third reaction is they are asking to convert 1 bromopropane to 2 bromopropane. Okay, so 1 bromopropane, let's draw the structure first. CH3, CH2, CH2 and Br2, 2 bromopropane, CH3, CH, Br and CH3. So in the chemistry here they are asking to change the position of this Br from this carbon to this carbon. Directly we can't do anything. Okay, so we do what? We eliminate this. So if you eliminate this here by the elimination reaction, that is called E2 elimination. Okay, and for that we'll take alcoholic KOH and heat. This elimination is called E2 elimination, also called beta elimination. Okay, so elimination means we eliminate the HBr from here. HBr means H from here, Br from here. Okay, so there is a double bond CH3 CH double bond CH2. Now from here to here, okay, here to here. So now we have a double bond. First step, which I hope clear for everyone. Here we have done what? Br from here, H from here. We have removed HBr by beta elimination, also called E2 elimination. For that we have taken alcoholic KOH. So HBr is getting eliminated, H and Br from here. So double bond we have to do. That is the step number 1. Step 1. Step 2, we break this double bond. Okay, and we add it, H here and Br here. So for that we have to follow the Markovnikov rule, Markovnikov addition. So we take here HBr. Okay, and this reaction is called Markovnikov addition. Markovnikov is the scientist name, Russian scientist. Markovnikov addition. So we have followed the Markovnikov addition. So the third reaction, what we have done, we have eliminated this Br from here. Along with Br, H is also getting eliminated. H and Br, double bond has introduced. For this elimination reaction we have used alcoholic KOH, alcoholic potash, KOH is also called potash, and heat. This reaction is basically E2 elimination, also called beta elimination. Okay, so HBr has been eliminated, H from here, Br from here. Okay, so there is a double bond between this this CH2 and this CH2. So now we have a CH double bond CH2. Then we have added the HBr by the Markovnikov rule, Markovnikov addition. So as per the Markovnikov rule, hydrogen is going to add to the carbon, outside carbon containing one number of hydrogen. Hydrogen gets attached to the carbon containing one number of hydrogen, and negative part will be added to the carbon containing less number of hydrogen. That is the Markovnikov rule. Now we have a next question. Toluene, first draw the structure. So this is the toluene here. 2, they are asking benzyl alcohol, CH2 and OH. Again, if you convert this one by anyhow in this one, I mean CH2 and Cl, then definitely the Cl will be replaced by OH by nucleophilic substitution. So you can take here, here you can take the, here you can do SN2, or you can take the SN1. Okay, so basically SN1 SN2 both can be done here. Okay, Cl will be replaced by OH. So, but we follow the SN2, so we follow the SN1 here. When a student they are following the SN2 here, you can do SN2 also, and SN1 is also possible, but rate of SN1 will be more here. So I'll cover this one in other video. Okay, so rate of SN1, this is another question by NCERT. I'll cover this in another video. So this rate of SN1 is more as compared to SN2. Both reaction is possible, but this one has more rate, so we prefer this SN1 here. So Cl is going to be replaced by OH by SN1 mechanism. But the thing is how to introduce the Cl here. So for that we have to replace one of the hydrogen by Cl, and for this replacement, that substitution is basically free radical substitution. So for that we take Cl2 and light. If you take Cl2 and light, this is basically free radical substitution. Okay, I'll mention here, this will be free radical substitution. Free radical substitution. Okay, now next question is benzene to 4-bromo nitrobenzene. I'll draw the structure first. Benzene to 4-bromo nitrobenzene. I've written delta. If you do the numbering from here, this will be 1 2 3 4 1 2 3 4 4-bromo nitrobenzene. So the thing is, in the benzene we have to introduce NO2 as well as Br. So basically 2 hydrogen we are going to replace one by one. So the question is, which one will replace first? Which one introduce first? Anyway, in a benzene, replacement is called electrophilic substitution. That replacement is basically electrophilic substitution. But thing is, we have to introduce Br as well as NO2. Which one will introduce first? If you introduce the Br, that process is called bromination. If you are going to introduce the NO2, that process is called nitration. The question is, which one will do first? So here in the nitration, if you do first, if you introduce the nitrogen in a benzene, okay, so nitrogen NO2 will be the meta-directing group. So with respect to this NO2, if you introduce NO2 first, because this is in meta-directing group, so with respect to this, Br will come at meta position. Okay, and if you introduce the Br in the benzene, this Br is the OP directing, ortho para directing. But with respect to this Br, this NO2 will come at ortho and para position. So better we go with the bromination first. I repeat. So if you introduce, see, anyway 2H they are going to replace in the benzene, 1 by Br, 1 by NO2. When you replace by Br, that is called bromination. When you replace by NO2, that is called nitration. Both are electrophilic substitution. Anyway, whenever there is a replacement inside the benzene, that replacement is called electrophilic substitution. So if you introduce the NO2 first in a benzene, okay, then with respect to that NO2, you can't, I'll do it one thing, I'll write it here. If you do the nitration first, for the nitration we have to take conc HNO3 and conc H2SO4. Okay, so NO2 we have introduced. This is the wrong path. I'll show you why we are not going to follow this path. And this NO2 is the meta-directing. With respect to this NO2, when you do the bromination now, if you do the bromination here, Br2 and FeBr3, this reaction takes place in dark. So with respect to this NO2, this Br will come at meta position, and actually we need Br at para position. So this is the wrong path. We are not going to follow this path. We are not going to follow this path. Then what is the correct path? The correct path will be, first we introduce the Br. If you introduce the Br first, I'll do it here only. If you introduce the Br, for that we have to take Br2 and FeBr3. Okay, Br2 and FeBr3. Then this Br has come in a benzene. This process is called bromination. Okay, now we do the nitration. HNO3 and H2SO4. So with respect to this Br, this NO2 for the nitration will come at para position, because this is ortho para directing. So I hope this is clear. So I repeat one more time. See, here we have to convert benzene to para nitrobromobenzene. So here if you introduce NO2 first in the benzene, that is the wrong method. So NO2 is the meta directing. With respect to this NO2, Br will come at meta position, but actually we need Br at para position. So we will not follow this path. This is wrong path. We are not going to follow this one. So what is the correct path? Then in that aspect, what we do, We introduce Br first, okay, by the bromination. This is the electrophilic substitution. So hydrogen of benzene will be replaced by Br. For that we take Br2 and anhydrous FeBr. I have not written anhydrous, it's supposed to be anhydrous FeBr3. Now this Br is the ortho para directing. With respect to this Br, NO2 will come at ortho and para position, but we need the para one, so we have introduced the para, okay, para position, okay, because this is ortho para directing and this process is called nitrogen. So I hope till here this is okay for everyone. So remaining questions will cover in the next video. So here basically I have covered the first 5 questions, remaining 5 and 10 questions, whatever questions are there will cover in next video.